Okay, we're going to move on to a topic called stopping distances. Although stopping distances in total is a good subject because I like to make up a question. Not a big cat lover, so apologies to any of you who are cat lovers. This video does involve a cat risking life and limb. Okay, let's look at some terms just to start with. Well, the first term that I want you to be aware of is let's say stopping distance itself. That's a good one to start with, since that's what I've already said. Stopping distance. Well, what is stopping distance? Okay, have a think. What do you think stopping distance means? And we've got braking distance. Okay, what does braking distance mean? That's probably one of the most obvious ones, but we'll get all the terms on the board first. And thirdly, what is thinking distance? So we're talking about a car that sees something in the road, and in this case, it's a cat. There's a cat in the road. It's not a very bright cat. It doesn't want to move. It's not even realised there's a car coming, and we're going to see whether or not the cat survives the encounter or not. So essentially what we've got here is we've got a car travelling at, we've got 32 metres per second. 32 metres per second. And there is a cat. Apologies for my cat. Um, 300 metres down the road. 300 metres. So, we need to look at these terms and see what these terms mean to see whether or not, when the driver applies his brakes, which are going to apply a constant deceleration of, let's say, 4 metres per second, so the acceleration is going to be 4 metres per second. So not very large braking deceleration, but one nonetheless. So when he applies the brakes, he gets a deceleration that's in that direction of 4 metres per second. What is the stopping distance of this car? Well, the stopping distance would be how long it takes for the car to come to well, the distance it takes for the car to come to a complete stop. From when it sees the cat and puts its brakes on to a full stop. So, what we're looking at here is this is the total distance travelled. So what is the braking distance and thinking distance? Well, the braking distance is the distance that's travelled once you've realised, oops, there's a cat in the road. Probably should put the brakes on. So you put your brake on you put your foot on the brake and you start braking. And at that point, the distance then travelled while the brakes are on is the distance that's the braking distance. So what then is the thinking distance? Well, it's the only distance that's technically missing on this board. So it's this distance right here. Now that distance is the amount of time taken for you to think about putting your brakes on. Now for some people that's longer than others, but in this case we are looking at a situation where you go, oh, there's a cat in the road, I should put my foot on the brake to stop myself from injuring that poor defenceless cat. So I put my foot on the brake, and the time taken for me to realise and do that, the distance I've travelled during that time is the thinking distance. Careful, I've already slightly almost made that mistake already. Lots of people try and define the thinking distance by starting out with, oh, it's the time taken for you to stop. Well, think about it, the term is thinking distance, not the time, thinking distance. So this is the thinking distance. And obviously, as we've already suggested, the total stopping distance is both of those added together. So stopping equals thinking plus braking for a car. Which means that any question that involves a car with a reaction time means that there's going to be a portion that is SUVA and a portion that isn't SUVA. Thinking distance is not SUVAT. Why is it not SUVAT? Now this is the question you should always ask yourself. Should you be using a SUVAT equation? Is it accelerating or decelerating in any direction? Over this distance, I've not put my foot down harder. I've not put my brake on. I've not reacted at all. I'm still traveling at 32 meters per second. And so, we are not going to use SUVAT here. We're going to use a simple velocity equals displacement over time to allow us to work out the distance traveled there. Now, if my reaction time is standard reaction time, portion per second, 0.7 seconds. You should now be able to rearrange this equation to work out a displacement or a thinking distance that has occurred before I go, oops, should put the brake on. The braking distance, however, again, we ask ourselves the question, is this SUVAT? Is the car slowing down or speeding up, or is it staying at the same speed? Well, it's slowing down. At least you'd hope it'd be slowing down since it's got a deceleration of 4 meters per second. So yes, it's going to be SUVAT. Okay, SUVAT question here. So you need to decide then what is the correct equation, and we've been through the equations, which is the correct equation you're going to want to use to work out a braking distance when you've got the initial velocity, the final velocity, the acceleration, and we want to work out the displacement. We're not interested in the time. So you decide which equation you want to use it, and in the lesson, very beginning of the lesson, we'll decide on whether the cat is going to survive this encounter or not.